Last week, Claude, my partner in crime, did something that shocked me so much that I changed my perspective of LLMs. I thought I'm far away from hitting the barriers, and most of the cases I am, but with this one specific one, not anymore. Check this out. I agree with Claude on something, and based on that, he wrote a couple lines of code. Results were crap, and I found out that this agreement was not reflected. And without no hesitation, Claude said, I forgot. How often you forgot about something what I said? I drastically changed the way how I work with LLMs. After this video, and this is a promise, you're gonna at least question if you should too. Let me explain. Context is the king, they said. The more complex you provide, the better answer you will get. But where is this context going to? Context window is a working memory of LLM. It includes every part of your interaction inside of one conversation. Your prompt, conversation history, all of the model responses, and documents which you provide. Also, every back and forth when something is going wrong. Okay, cool, context window. How big it is? To make it easy for us users, Sam Altman and other AI wizards provide context window size in tokens. ChatGPT 4o, 128,000 tokens. Cloud Opus, 200k. Google Gemini, 1 million. Okay, 1 million. That's good, huh? Token is the smallest chunk of text which LLM can process. People read text in words. LLM read text in tokens. We see restaurants as a one word. LLM see 2 or 3 tokens, depends on the model. Providing context is like training. More training means better results. But there is a point where more training will not give you better results anymore. It's actually gonna hurt your performance. LLMs are similar. At some point, more context gonna make your GPT worse. This is called context root. In my opinion, this topic is absolutely critical. And to give you all of the what and hows, we will do 2 stops. Today, we're gonna talk about what context root really is, how it starts happening, and when it goes south. And next week, we're gonna focus on winning techniques, sandwich method, memory bank, and hard wipes. Let's start it. Have you ever seen a car ad where they said the new model burns only 0.7 liter at 100k? Context window and fuel consumption reports are basically the same thing. You're gonna see them once. Let me explain. In April 2024, NVIDIA tested this. They created a benchmark called Ruler, a standardized test for AI models. 10 models, 13 different tasks, context size 4,000 to 128,000 tokens. The results? All of these models claim context size of 32,000 tokens and more. Only half of them could maintain performance at this length. And it gets worse. Every model aims at simple test, finding one piece of information in big document. But when NVIDIA made it harder, multi-hop reasoning, connecting dots across multiple pieces of information, or aggregating or pulling together information from different places, performance dropped hard. Even ChatGPT 4, the best performer, dropped 15 percentage points when pushed to 128k. The pattern held across studies. Effective context, where the models still perform okay, is roughly 50% of that what they advertise. I call this 50% rule. The 128 context window, plan your work around 64k. AI company isn't lying. The model can process 128,000 tokens, it just won't do it well. That's what happened with documents. Relatively simple test. Conversation, more complex structure, this is a different story. Every LLM conversation is ongoing battle between what matters, the signal, and what doesn't, the noise. It's very similar to human conversation. Our conversation are not math equation. There is always a little bit of fluff. When you ask a stranger on the street what time it is, most likely you will go, excuse me, what time it is? Signal, the most important part, what time it is. The noise, important but still noise, excuse me. In GPT conversation, signal is core requirements, information model is to follow, or restriction. Noise, back and forth debugging loops, rejected approach, and my favorite one, the model rich explanation you didn't ask. AI treats everything in your conversation with equal weight. Your original instruction from turn 1 up to last turn with this is not quite right. The transformer attention mechanism, the way how the model decides what to pay attention to, used softmax normalization. In very oversimplified terms, that's a math rule that creates a fixed attention budget. The more tokens, the less any single token can receive. It can just focus on what's matter. With 100 tokens, the model can give any single token up to 1% of attention budget. With 1,000 tokens, that ceiling drops to 0.1%. Important things still get more attention than noise, but the maximum possible focus keeps shrinking. It's like trying to hear a specific voice in increasingly crowded room when everyone speaks the same volume. The longer your session, the more debris. The more debris, the worse your results. So the debris piles up, but there is a specific way your AI breaks when you ask to track too many things at once. And that brings us to another problem. AI can't juggle. There is a test called needle in a haystack. You hide one piece of information in a massive amount of text and you ask AI to find it. This one is important and practical, and you really might to change the way how you work after hearing this. March 2024, Google Gemini was tested on this. A synthetic phrase was hidden inside repeated copies of the same Paul Graham essays. One needle, 99.7 accuracy. 100 needles, 60%. Not great, but even those numbers are inflated. Real documents with natural information perform much worse in a third-party testing. How much worse? In February 2024, GDELT Project tested Gemini on actual TV transcript, 70,000 tokens, looking for every mention of Biden, US president at the time of the recording. The model caught only 19 to 27% of them. And this is a multi-needle collapse. Same test, but with hundreds things to find instead of one. AI attention have to split. One target, it's easy to focus, but 100 targets competing for the same fixed attention budget, things get missed. Let me put this in the context of a daily work. If you are working on a multi-dimensional task in one conversation, you're asking for a problem. Lately, I'm spending a lot of time on YouTube. Research, title, thumbnail, script, description, sources, a lot of different topics with massive amount of text. I split the work into related chunks and work on them in separate projects and conversation. Real work is difficult enough without babysitting AI. Use it wisely before it's gonna backfire. Here is the most challenging and dangerous part. You won't know when this starts to happen. And this brings us to the final problem, which is no warning sign. Context route starts slowly. LLMs are really good at making stuff up, and it's challenging to see the smoking gun. The critical early warning sign is a production of logically sound nonsense. The produced text is grammatically correct, it sounds good, but it is against the constraints. Two specific situations to pay attention to. First one, subtle logic drift. You are having fun, conversation is going on, and you start seeing some subtle logic drifts. It's not an obvious hallucination glitch yet, that AI is making stuff up. It's rather something small, different date on a different file the AI is referring to, however, is as confidently as hour ago. And the second, not keeping established rules. Model starts suggesting solution you either agree earlier not to do, or specifically stated in the very beginning in a do's and don'ts section. GPT models, when they lose track, they tend to hallucinate confidently. They will give you an answer, it will sound right, it won't be. Cloud models do something different. When they detect they are losing context, they're more likely to say, I can't find this information. However, I'm yet to see this. Let's bring this home. 50% rule, context window size information is as usable as fuel consumption report. Plan for half. Conversation debris, all of the back and forth, hides your original instruction. Keep the fluff to minimum. Multi-needle collapse, keep the topic relevant, split the work into separate conversation if not related. And the last one, confidence trap. The AI won't tell you when it's lost. It will just keep going. This is happening way more often than you think. And that's closing part number 1. In part number 2, we're gonna focus on winning techniques. Every source I mentioned in this video is linked in the description. I sort them by the claim, so you can challenge me on anything what I said. Are you curious if your old prompts working with new models? I made a video about 6 tricks which recently stopped working. If you want to level up your game, link is on the screen. I'm gonna see you there.